Hello guys, welcome back. In today's video, we have object-oriented programming in Roblox. This is definitely going to be one of the more important videos, as object-oriented programming is a fundamental key of every single coding language and every single thing you're going to do with programming from now on. Roblox Luau, for example, is an object-oriented programming. Everything is an object in here. For example, if I say v instance.new, I have all of these different objects of the instance class. This is how Roblox works, and all of these different objects, they have all these different attributes and methods and whatnot. And that's how Roblox functions for us, at least. Now, and if you're coming from other languages like C++, Python, even JavaScript, you know that object-oriented programming has its own special syntax. Roblox doesn't do that for us, or Lua doesn't do this for us in specific. We actually have no way of doing object-oriented programming, which is why we're going to be using something called metatables and tables to basically make our own object-oriented programming in Lua. Now, this is the conventional way to do it, and you're gonna see that in very big AAA games that they in their systems they use object-oriented programmings. But what is an object-oriented program? What is an object really? So before we dive into objects, what is a class? A class is a blueprint, right? And an object is literally a child of that blueprint. It's a subset of the blueprint, if that makes sense. It's made through that blueprint. For example, every human, or yeah, all of us are from the class of humans, but we're all separate objects, if that makes sense. The class gives us default data like our eyes, skin, nails, the color of our skin, eye color, all of those different things, right? But not eye color, sorry, those are specifics. Like we all have legs, arms, eyes, ears, mouths, lips, and whatnot, right? That's our blueprint. This is how humans are. But each object, each different person of that class has different attributes and has different values of those has different like of those default values, if that makes sense. I'll have brown eyes, while this next guy has blue eyes. That object, that other guy, he's an object of the human class just like me. His blue eyes might be, his data on the table might say blue for for eye color and might say brown, if that makes sense. So in the summary, in little retrospect, a object is an inherited method from a class, not inherited method, sorry. It is a way to get from a blueprint and manipulate that specific object. So let's start making it and let's stop the yap. So before we actually do anything, we need to make our table, right? This is why I'm gonna use a module. I named it class just for now. I put it in server script service, so go ahead if you want to. And I made a table right here. And in this table, I'm going to specify dot underscore underscore index. So I'm going to say dot underscore underscore index is equal to the player object. Now, what does this mean? Why am I referencing this table and saying its index is equal to itself? Well, what this index method does, this allows for us to use meta methods in our tables. Now, if you don't know what a meta method is, we can say set meta table. And what's going to happen is if we set this meta table, what's going to happen is that if we look for some sort of value in this table and we don't have it, what this is saying is look back to here for that value. And if it's not initialized, well, if you look here, we'll find the default data in here. That's basically what this is saying. This is a callback, and it's saying to call back to this to find some sort of value. Let's say I let's say I make a new object, and then I say I want to add a eye color, but I don't specify, I don't specify eye color, right? It's going to look into here and set that default value. But if I do specify, then hey, we're not gonna touch it. That's how that works with this dot underscore underscore index. This is a meta method. And meta methods are this specific meta method. It's gonna let us use default values as shown, and this is the most important one really. There's another one I low-key forgot what it was, but there's multiple. But this is the only one you're really gonna use, to be honest. So like I said right here, if a player is created without defining the name, then dot underscore underscore index lets a table refer to a default value. Now let's actually just get started to making So the first thing we can do is we need to store inside of this player object table. We need to say dot new, and this is the conventional. This is the naming the standard for making a class in Luau, you just say dot new. You could say dot whatever, but new is what you're gonna see in every single system that you see. Then what we're gonna say is we can just hit enter, and then we can take in some data in here as well. But we're not gonna do that. Matter of fact, let me just Control Z, and let's get back our old function that we had. Okay, let me get rid of this, and there we go. Okay, now as you know, if I make a new function for the player object and I use this colon, well, I'm gonna get this new parameter passed in called self. And what this is referring to is literally just this table that's calling it. If this is a different table, for example, function like here, let me just say local v is equal to this v, and then whatever. Self in this case is going to be v, right? However, and let me just say like new, right? Function or self in this case will be v, but in this case, self is going to be the player object. So that just clears some things up. Self is not referring to the module script; it's referring to whoever is actually calling this function. And self is automatically passed if we use this colon. Now, if we don't use the colon, we say dot, then we can just call it in a second. We can actually just pass it through, but we're not gonna do that. Let's say colon right here, and it'll give us self. But I wanted to clear that up because we're gonna be using a reference operator, this dot, to make the new class. The reason why is because you'll see in a reason. If we use self in here, what this is going to do is that whenever we call this, it's going to be, it's a little tricky to explain, but basically we're calling this on the class itself and not the object. It's a little weird to explain. It's nothing crazy, but it's not, like, it's relevant, but it's not too crazy. Like, it's nothing important, really. So now we need to actually define our own self. Now, we don't have to call this self, but regular naming conventions in coding, calling this self is standard, usually. And self is just going to be our way of making a class. So let's say equal to, and now we have to just set metatable. Now, if I set the metatable, what this is going to do is this is going to allow object-oriented programming. This is going to allow for this dot underscore underscore index to actually work as well too. So this is going to set the given metatable of a table and the table to set the metatable of. So this is going to take in a table at first and then a new metatable. So two tables. So I'm going to put in an empty table. So it's going to refer back to an empty table, and then I'm going to set player object as the new metatable. So the second argument is saying what do you want to be a metatable, and what table in the first one do you want this to fall back to, basically. So if I pass in no name, it's going to fall back into the name value into here. And you might be wondering, well, there's nothing in here, so how can I do that? Well, it's pretty easy. You can simply just say self.name is equal to, and then I'm going to just pass in this name that we pass in. Perfect. Now this table, because self is this table, this metatable, is going to simply just take in name. Or it's going to have name as well. And then I can say self.health equal to 100. Self.speed. Perfect. 20. And I use a capital X. And there you go. And then we just simply need to return self. Now, let's actually call this module script and let's make a new class or new object using this class. Now, you see how this works? This is the blueprint. This is what every single object we make with this class is going to have by default. Now, you could also do this, local default data, and then you can just say name is equal to player, health is equal to 100, speed equal to 20. And then you can pass it through here. This will be the default This will be default data as well. Because remember, that first argument is default data. And if I don't find health, speed, or name, it's going to actually come back here. But if I specify it into here, if I actually pass it through, then it doesn't have to do that. But this is kind of redundant because we're said self is equal to this. And then we're just kind of, redoing this all. So let's not do that. Let's actually just make a new table instead. That's better code hygiene anyway. But yeah, now let's actually hop into server script service. I'm gonna make a new class. I'm gonna call it objects, and let's reference our class scripts. Class module require script dot parent dot class. Yeah, there we go. because they're in the same service right here. Now let's make a new class. So now I can just say local player 1 is equal to class module, and look at that. I have these new class this function I can make. Player 1. That's the name I passed in. And now I'm gonna print out player 1. And then I'm gonna actually print out player 1 dot name. I'm gonna print out player 1 dot health. Print player 1 dot speed. And now let's see what happens. And matter of fact, let's make a player 2. But let's not pass anything in. And then I'm gonna print out player 2 dot name print player 2 dot health, and then we're gonna print out the speed as well. And now in here, let's actually give some default values. So we're saying this is equal to this, and let's just say this health speed. And then we can simply say in here or we can do the default data. Either is fine. We can say or player or 30 or 20. And I'm gonna actually say this is 100. There we go. Player 1, I'm gonna give him a health of 100 and a speed of 20. And I'm not gonna do anything for this boy right here. There you go. And look at that. So let's see. Why do I have 2 outputs? And now we come into objects. I printed out player 1. This is what he has. He has health, name, and speed. And then we printed out his name, which is player 1. His health, I specified 100 and then 20. Now player, this is the name that I gave player 2 because we didn't specify a name. What we can do, we don't have to do this. We can simply just pass in, honestly. I'm thinking of systems on the spot. We can say name, health, speed. And what we can do here instead is we can just make methods. So what methods are is a way for objects, for example, local player 1, class module.new, player 1, 120. And then I can call methods from him. So I can say function, player object, change, like we can do that. We can change speed. New speed. And what this is going to do is because we use this colon, we actually have the self object or a keyword already. And now look at this. If I call player 1, I can now change speed just like this. These are methods that we curate to our objects. You might notice this in other instances like humanoid. Like let's say we have this thingy, and I say humanoid is equal to script.parent, some bullshit, right? We have all these objects or these methods that we can use, right? And we're doing essentially the same thing. So then we can change speed. So then I can say self.speed is equal to new speed. And self is the player object. And then I can print out speed changed for, and then we can say self.name. And that works. Oh wait, I can't edit it wrong. There we go. And now we change the speed. I'm going to say 35 or 30, right? And then we can say if not new speed, then return end. If they called it by accident, then we don't want any errors, right? Call it speed change for player 1. There you go. Our speed is now 30, which is really useful. And yeah, that's really about it for object-oriented programming. It's a really simple, introduction to it. I encourage you guys to make your own systems with this little knowledge you've gained, and then make something that's really cool. If you want a really good way to apply this, I recommend using this for like RPGs, battlegrounds, whatnot. But specifically, the party system tutorial that I made, like Tower Defense Simulator, the party system tutorial, it's on my channel. You guys can go watch that. I use literally these methods, and I use object-oriented programming to make each party. Each party is its own object of a blueprint with all the party members and everything. So yeah, I hope you guys enjoyed. I'll see you guys in the next video. Goodbye.